So this is section 8.1c in Algebra 2. And to get started, we're going to do kind of a quick refresher of what we talked about in the last class or previously. So look at number 1. Remember we said if you raise a power to a power, you multiply your exponents. Well, if I multiply 4 times 1/4, right, and I think of this as being over 1, since you go straight across, wouldn't that be 4 over 4, which is just 1? So when I multiply 4 times 1/4, I just get x to the first. And no, you really don't have to write the 1, but I just wanted to show you that I was multiplying my exponents. So go over here to number 2. If I multiply my exponents, I'm going to have 3/4 times 4/3. Again, won't that just be 12 over 12, which is 1? So if I multiply my exponents, I just get x to the first. Well, notice I multiplied 3/4 by its reciprocal. Same thing over here. I multiplied 4 by its reciprocal. And anytime you multiply a number by its reciprocal, won't it just cancel out and equal 1? Okay, so if you look at number 3, think of cube root as x to the 1/3. Remember, that's cube root. And then that cube root is being raised to the third power. So if you multiply your exponents, right, they're reciprocals, so that's going to become x to the first. And so what I wanted to point out is if you cube a cube root, it's kind of like the cube just cancels the root. Same thing over here on number 4. Since you've got the fourth root of something to the fourth, it's kind of like the fourth root just cancels the 4 and you just get x. So with that in mind, on number 5, if I want to solve for x, there's two things I have to do. First, I want to get rid of the 13, and then I'm going to have to figure out how to get rid of the 2/3. All right, so I'm going to start by subtracting 13. So I've got x to the 2/3 equals 4. Okay, well, if I want to get rid of the 2/3, kind of like we did up here on number 2, to get rid of a fractional exponent, we just raised it to the reciprocal power. So I'm going to raise this whole thing to the 3/2. The only problem is, whatever you do to one side, you have to do to the other side. Okay, so on the left, the 3/2 and the 2/3 cancel, and I just have x. On the right, this is what we talked about yesterday. The 2 means square root of 4, which is 2, and then 2 to the third power is 8. Okay, on number 6, so first I need to get rid of that 3, so I'll divide. So x to the 3/2 equals 125. Okay, and then if I want to get rid of the 3/2, I would raise it to the 2/3. Whatever you do to one side, you got to do to the other. So on the left, those cancel and I just have x. On the right, so remember the denominator is 3, so cube root of 125 is 5. 5 squared is 25. Okay, number 7. Oops, sorry about that. Okay, first get rid of the negative 2. So x to the 3/4 equals 8. Okay, in order to get rid of the 3/4, I'm going to raise it to the 4/3. Both sides raised to the 4/3. And so on the left, the exponents cancel and I just have x. On the right, the denominator is 3, so the cube root of 8 is 2, and 2 to the 4th is 16. On number 8, first I get rid of the negative 2, so x to the 1/4, I'm dividing, right, so equals 1. And then how do I get rid of an exponent of 1/4? Well, the reciprocal would just be 4, so raise it to the 4th power. So on the left, they cancel, and I just have x. On the right, 1 to the 4th. Well, 1 to any power is just 1. So this is just going to be 1. Okay, now, number 9, don't get confused. You can't add 4 out of that parenthesis, right? Because you got to get rid of that exponent first. So I'm going to go ahead and raise this whole thing to the 3, because it's the reciprocal. So both sides to the 3. And what I have is, on the left, it cancels the exponent, and I just have x minus 4. On the right, I have 8 to the 3rd. Well, I know that 8 times 8 times 8 is 8 to the 3rd. And I know 8 times 8 is 64. And then I would have to do 64 times 8. And just a little, for reference, I wouldn't make you do that without a calculator, even though it's not that hard, right? You could do 64 times 8 and do the multiplication, carry your 3, 48, what would that be, 51? So you could, multiply it out and get 512, but I wouldn't make you do numbers like that on the without a calculator. Last step, in order to solve for x, I can add 4, so x equals 516. Okay, on number 10, again, before I get rid of the 2/3, you always want to get rid of whatever's being added or subtracted here first. So I'm going to have x plus 2 to the 2/3. And if I subtract 3, I'm going to have 4. Okay, so now in order to get rid of the 2/3, I raise the whole thing to the 3/2, both sides. On the left, the exponents cancel, and I just have x plus 2. On the right, okay, start with the denominator. So it's the square root of 4 is 2. 2 cubed is 8. So in order to solve, I'm going to have to subtract. Okay. Now this page we've actually done before, so I think it might look familiar. If I want to solve for x, so first I get the square root by itself, so I'll add 3. So the square root of 2x minus 5 is 10. And then remember we said in order to get rid of a square root, you would have to square it. So I square both sides. I'm going to have 2x minus 5 equals 100. So now solve for x, so add 5. And by the way, I would have no problem asking you to do this one without a calculator. And then divide by 2, so x is 105 over 2. Because I don't even want that as a decimal, just leave it as 105 over 2. Okay, and then notice here I've got a square root on both sides. Well, when you square both sides, won't both of them cancel? So you just have 3x minus 8 equals 5x plus 1. So now solve for x. Let's see, move the x's to the same side. So I'm going to have 2x. And then if I move the 1 over to the left, that's going to be negative 9. So x equals negative 9/2. I think that's right. We won't do problems like number 13. And then look at 14, last one. So I know I'm going to have to square both sides. Okay, so I'm going to have on the left just x squared minus 8x plus 19. On the right, when I square it, I get 4. Okay, so this one's a little different because notice it has a squared term in it. And how do we solve problems that have a squared term? Don't we set them equal to 0 and factor? So I'm going to subtract that 4. So x squared minus 8x. Let's see, if I subtract 4, that's going to be plus 15. And so now can we factor that? I think so, right? X and x. I know both signs have to be a minus. And I'll go 5 and 3. That's going to work, right? That's going to give me the negative 8 in the middle. So that means x is either 5 or x is 3. How did I know I had to factor? Because I noticed it had a squared term on it. Okay, so that is section 8.1c, and the homework is on page 61.